Hello, everybody. Greetings and welcome to the IFTDSS webinar on the landscape burn probability model. Happy holidays, everybody. We're really glad everybody could attend. Let's see, I think folks are still logging in. So as that's happening, I just want to go over a couple of details and then introduce our presenters today. First of all, we have Caroline Noble, who is one of the IFTDSS technical leads. Caroline lives in Tallahassee, Florida, and works for the Forest Service as part of the Wildland Fire Management RDNA group. And she is going to be presenting sort of the introduction to the landscape burn probability model. And then we also have Jennifer Anderson, who is the fire planner for the National Forest in Florida, also in Tallahassee. And Jennifer is one of our experts on risk assessments and things related to that type of analysis, and she's going to be showing us how to apply the model that we have in IFTDSS to some actual project work that they have going on in Florida. So that's sort of how we're going to go through the webinar. Caroline will start, and then Jennifer will jump in for the second half. And a few things, since we've got a ton of people joining the webinar today. So in order to make sure we're able to answer questions as they come up. If you have questions, we're going to keep everybody on mute because of the large group. But if you have questions, please use the question box on the control panel for the GoToWebinar. And you can, when you type your question, it'll be if you select to send to everybody, then everybody can see your question. And then myself, and I'm Kim Ernstrom, by the way. Sorry, I didn't introduce myself. I'm also with the Wildland Fire Management RDNA, and I'm one of the other technical leads for IFTDSS. And so I'm going to be helping answer some of the questions as they come in, as well as Josh Hyde, who works for the University of Idaho, is our chief expert on the user support system in IFTDSS, and will also be helping answer some of the questions. So we'll do our best to get to those questions as they come in. And then following the webinar, probably within a day or so, we're going to try to have the recorded webinar ready to go and posted to the IFTDSS homepage. And Caroline's showing you right now, it'll be under the user support section under webinars and trainings. And that's where the recording will reside. You can see there's a recorded webinars tab there. And we'll post the webinar there. You can share it with your friends. I'm also planning on having the questions and the answers as another piece that you can look at with the recorded webinar. So that way, if you have questions, you'll be able to take a peek at those and see what the answers might be. Okay, so hopefully everybody can hear us okay. If you have any trouble seeing the screen or hearing anything, just type in the chat box there and let us know that you're having an issue, and we'll try to get things fixed. And then certainly any questions you have, throw those into the box. Okay, we've got a lot to cover today, so I don't want to take up any more time. And I think we'll just send it on over to Caroline, and she's going to jump right in. Take it away, Caroline.
Thank you, Kim. Can you guys hear me okay?
Yes, I can hear you well, and I can see your screen is your first slide, okay. I believe.
Okay, great. Thanks, Kim. So just a little bit of an outline of what I want to talk about today. Specifically, it's the burn probability model in IFTDSS, and we're presenting it as part of the quantitative wildfire risk assessment process that's being built in IFTDSS. So as a result, I'm going to do a little bit of a risk overview to show how burn probability fits in to risk, and then specifically talk about what we've built for burn probability in IFTDSS using a slideshow. And there's quite a bit to cover, so buckle up. And time permitting, I'll walk through a little bit live in the application, but we want to save time for Jen's application example, where she's also going to show some of the live online. So that's sort of the structure for today. So the first thing I want to talk about is landscape burn probability, just what that means. There's not a lot of burn probability models out there, but just to orient everyone, IFTDSS is using the FlamMap suite of models, specifically the model called RANDIG within FlamMap, short for random ignitions scattered across the landscape. This says FlamMap 5, but since we're actually running models off the cloud, we're using the most current version of FlamMap models available as soon as they're available. But the key point here is that this is different from FSIM, it's different from FS Pro. Those are all probability models. The difference being, and I'll talk a little bit more about this, but FSIM is for an entire fire season. It has a different purpose. It's more fire management planning used at the national and regional scale. And IFTDSS is really for a problem fire scenario, a worst case extreme weather scenario, only looking at one or a few burning periods. So that's the difference between them. And I can elaborate on that just a little bit, taking that a point further. And tying this to risk, we are using the same risk assessment process that's used in the national risk assessment and a lot of the regional risk assessments that have gone on and are being published or ongoing. GTR 315 for those of you that are interested. And that publication, calls for the use of either RANDIG as a probability model or FSIM. So IFTDSS is using FSIM. And like I said, the intent is for slightly different uses. And the main differences are that FSIM looks at weather over time, whereas in IFTDSS, it's a user-specified single set of inputs for a worst-case scenario. And FSIM tends to look at the entire fire season. And then FSIM also is calibrated with some suppression efforts, suppression success, line building rate, capacity, that sort of thing by fuel model. That's not accounted for in the burn probability model within IFTDSS. So those are the two big differences, and they are significant. So the why, why are we building this additional burn probability model? It was called for by agency leadership, and it was actually just very recently explained to me that its purpose is well, I knew the purpose, but how they're going to apply it, or they hope to apply it, is more at this unit and project scale. So we've got a national risk assessment that may be looked at for funding allocations, to the regions, or a consideration, certainly not the only one. And then similarly at a regional or state level, depending on the agency, again, we'll look for the high probability areas within that region, potentially for funding allocations, and various regions have this completed, various ones are in progress. But IFTDSS comes into play more here at the unit level, so that could be a forest, it could be a district, it could be a park, could be a cross-boundary ownership, on down to the project level. And it's really more for project planning and then prioritization within that unit or within that project in terms of risk reduction, and comparing treatment alternatives to see which one's going to achieve the objectives of those specific projects. And you can see with this example, like what shows up, as high probability at a national scale is certainly not necessarily going to show up as high probability at the state or unit scale, and vice versa. Each one is calibrated to its own analysis area. So it's something important to keep in mind as you're looking at this. Everything has to do with scale of the outputs for that specific analysis. So even within IFTDSS at the project scale, you can't necessarily compare red in one project area to red in another project area. They're each dependent based on the landscape extent. And I'll explain that further. So within IFTDSS itself, we've broken the development of the risk assessment into 4 phases. Simulate wildfire, map values, conduct an exposure analysis, and then complete a quantitative risk assessment. So these check marks signify what's already completed and released within the application. So we have the ability to calculate the landscape burn probability, and we have this map values functionality. The next step will be the exposure analysis, which looks at the HVRAs, or the highly valued resources, in relation to burn probability outputs in a report and on a map. And that's due to be released probably early February 2020 is our hope. And then after that will be the full quantitative risk assessment, which takes into account the response functions, relative importance, both the net threat and the net benefits associated with fire. So the reason we're releasing it in phases, really, there's two reasons. One is this is new stuff. You guys are not taught landscape burn probability in your NWCG classes, and we want users to start getting familiar with it and playing with it rather than bombarding the user community with a full-on risk assessment at the release. And second of all, these products can be useful as standalone products. Both the burn probability and the map values can be looked at standalone or in conjunction with one another, and we want it to release those rather than holding them back from people to start utilizing. So as I alluded to, these things they all fit together to build a risk assessment. This is sort of the whole flow of a risk assessment, but we're focusing in on the dotted line today, the landscape burn probability. So you've got your weather, landscape, and ignitions, calculate a landscape burn probability, and generate a map and a report. Last week's webinar, I think, gave an overview, or a couple weeks ago, of this entire risk process, and then focused in on the mapping values, identifying highly valued resources and assets, and looking at them on the map. So these two can be used in conjunction, but today we're just going to look at burn probability. So when you look at this in the context of a full risk assessment, you can see here on the right, this risk triangle, you've got likelihood, intensity, and susceptibility. So with burn probability, we're covering two legs of this, or two sides of this triangle, the likelihood and the intensity. In the schematic over here on the left, you can see that a burn probability simulation results in three outputs: burn probability, conditional flame length, and then a derived product called integrated hazard. So those are the three spatial outputs and the three things available in a report you'll get from IFTDSS when you run burn probability. Just to zoom out just a little bit to orient people maybe who haven't been tracking very well. So right now when you go into the application, there's going to be two models available instead of one. There's shown here in the modeling playground, you've got a choice between landscape fire behavior and landscape burn probability. I pulled this up right from the help content within the application, some things to help you determine which model is the appropriate one for the questions that you're wanting to answer. So landscape fire behavior, again, these are based on the FlamMap model. So this is FlamMap Basic, and this is RANDIG, which is really a number of thousands of MTT runs looking at probability. Landscape fire behavior is at the pixel level, and landscape burn probability spreads fires across a landscape. So the pixels are not independent as they are in landscape fire behavior. And landscape burn probability is probabilistic, meaning you're going to get varied outputs each time you run it, even given the same inputs, whereas landscape fire behavior is deterministic. You'll always get the same outputs, with the exception of if you have spotting on, which is random. And one of the bigger differences is that the outputs for landscape burn probability are uniquely scaled for each analysis area of interest. Changing the area of interest for a report or masking an output for landscape fire behavior will not change your outputs. That's sort of the model differences, but in terms of the questions that landscape burn probability are really going to get after more are which areas on the landscape are more likely to burn than others. It's that likelihood and intensity. So how likely is my ownership going to burn as compared to an adjacent ownership or some in-holdings? How is that intensity going to compare? But you'll see that some of these questions blend. You probably want to use both models to answer some of the questions. Will this area benefit from treatments, depending on your objectives? Sure, you can look at both models. And keeping in mind that with burn probability, the objectives are limited to really looking at reducing fire intensity. And so the likelihood and the intensity, we're not yet taking into account any sort of values or resource-related objectives at this point. So that's just a quick overview to sort of orient you to the two models currently available in IFTDSS. In the application, the steps, I've sort of put some steps together here, but I think one thing to keep in mind is that some things are prerequisites to other things, but you don't necessarily have to go in order for all of these. So you will need a landscape in order to run the model. So the first step is always create a landscape when you log in and you go to this first portion of the fuel cycle. landscape evaluation, that'll be your first card there, is to create a landscape. Second may be to edit the landscape if you want to either put a treatment scenario on there, or you know that there's edits that need to be made because the land fire data you're using needs to be rectified or is not current. That would happen during the edit landscape. Then you'll run the model itself in the playground. And then these next steps of viewing the results, generating a report, downloading results, there's all buttons available from the workspace for you to do that. There's also buttons available for you for most of these within the playground where you've run the model, and I'll show you each of those. So those are the basic steps. I'm not going to go into too much detail about creating a landscape. We've got training materials on this. Probably the most significant thing is we've got 2012, 2014, and coming soon, hopefully sometime in January 2016, land fire data where it's available, which is a good chunk of the western portion of the country. And then in the map interface, you either draw a bounding box or you can create a landscape using an area of interest or a shapefile. The current rectangular extent limit is 3.5 million acres. We automatically buffer the landscape by 5 kilometers on each side, and that's to eliminate the edge effect and allow during this burn probability calculations to allow fires to enter and leave the landscape and spread across it. So that's automatically applied. You'll see in this screen capture, so the turquoise box might be what you drew, and then this buffer outside of it is automatically applied, and this is referred to throughout the application as the landscape extent non-buffered. And then this is downloadable for use outside of IFTDSS as well when you generate that landscape. The second step is that landscape edit card that I showed you. Again, I won't go into too much detail on this. You've got the disturbance edit rules that are available that are shown here. These will not be available with the Landfire 2016 data, just because they're changing the way they classify a lot of the ecological information. We're going to have to generate a new set of lookup tables for that, and that's going to take a while. So something to keep in mind, that if you want to use those edit rules, you would have to be working with 2014 or 12 data. You will be able to still use the user-created or global edit rules that are available by attribute. And again, this is downloadable within the application. The next step would be just entering the model inputs and or validating some of the default values that are populated. You go in and you select landscape burn probability, and you'll have choices about wind type, speed, and direction, crown fire method, and foliar moisture content. Some defaults are in there, and I'll show you when we get to the app, but it always uses gridded wind. The crown fire defaults to Scott and Reinhardt with a foliar moisture content of 100%. There is fuel moisture conditioning available. The default is that it's off. We do have classified extreme conditioning data available for the Western US, or you can upload your own if you have a conditioning file for other portions of the country, or if you prefer that over some of the default data. And you set the simulation time, which is to represent the length of the burn period during fire spread in one of those worst case scenarios. I think that ranges from 4 to 12 hours. And you set the spotting probability, which is different than what people might be used to in using like near term and WFTDS. So you might want to read up on the spotting. It will default to 20%, which is an appropriate input for this model. There's some inputs that are controlled by the application, namely the number of ignitions and then the landscape resolution. The system automatically figures out a resolution based on landscape size, and I'll show you some information on that, and also then how it keeps running fires until it hits hopefully the target of 98% of burnable cells burned across the landscape. That target is not always met, but that's the goal when the model is running. So just a note about the way this works, this random ignition process, thousands of ignitions are thrown onto your landscape, your buffered landscape, and only the ignitions that land on burnable fuels ignite, and those fires spread. each fire, spreads with the conditions specified, and each fire runs independently. So any spread from one dot is not going to affect subsequent runs. And the weather conditions are held constant. The same burn period is used for every one of these ignitions, and it keeps on burning until ideally 98% of the burnable cells in this landscape have burned, and then you get a value for how many times each pixel burned, and that's your burn probability. You can see here, this is an example of, you've got the coordinates of the random ignition and the acres of those individual fires. If you download the model output, you will get this called a fire size list that has all this information for further analysis. And just to note, coming soon also will be the ability to reuse the same ignition file. It'll still be initially a random ignition, but since people want to be able to repeat that in order to compare treatment scenarios, we're going to have the ability to reuse a specific ignition file that the user can specify in the release. When we release exposure analysis, that's going to be part of it. I mentioned that the automatic resampling occurs. This is in order to balance the computing time and computing power and the model efficiency. So it depends on the landscape size. This box on the right here shows that it'll remain at a 30-meter resolution for landscapes under 250,000 on up to 120-meter resolution at the larger landscapes greater than 2.5 million. If I didn't emphasize it, the maximum landscape size, where was that? It's 3.5 million acres, I believe. Is that, or maybe it's 5 million. I can't remember. It'll tell you if you've gone too big. And once this resampling occurs, your model name will actually be appended with the resolution of that, as well as some other places in the header in the right-hand panel, so you're aware of what resolution was used in the analysis once the automatic resampling occurred. When you actually hit run on the model, got a little patience grasshopper here, the run durations vary. It's based on your landscape size, based on the fuel model, it depends on the inputs you put. It's really important to remember that this is for worst case planning, 97th percentile and above. The drier and flashier the fuels, the faster it will run, but that's not the reason to use those. I mean, that'll make it run faster, but the model was intended for this problem fire scenario. So putting in higher moisture contents is not only going to slow down, bog down the model, potentially resulting in a failure, but it's also not going to give you valid outputs. On those longer runs, it can take hours. Shorter runs take minutes. I can't really give you an average time. It just depends. So while it's running, you can check the status in the right-hand panel of the playground. There'll be an in-progress fire summary that's every time you hit pathologically, hit the refresh button, you'll get the number of fires run so far, number of fires failed, if any, and then the percent of burnable cells burned. So this is trying to work its way up to 98%. This can go up to well over 100,000 fires, depending on the landscape and the fuel moistures and the fuels themselves. And then in the workspace, you will only see it when it's completed. You will have running here in the playground view, and you can go away and do other work, and you'll get an email notification once the model run is complete, so you're not sitting there waiting for it. Also here you'll see you get a run queue position. This says 1 of 1. I think we can run up to 4 Randig models at once, so it could say as much as you're 4 of 4 or whatever. That'll give you a little indication. It's not going to give you a time estimate, because we really can't do that, because it doesn't know how many fires it's going to have to run, but we can tell you where you are in the queue. So that will continue to update as you hit refresh as well. So once you've run the model, you're going to view the results on map. Just to review, you're getting the likelihood intensity under a fixed set, so your outputs are going to be burn probability, conditional flame length, and integrated hazard. These 3 outputs. This is what the layer list looks like. You got a checkbox for the burn probability, checkbox for the conditional flame length, and then checkbox for the integrated hazard. Each of those 3 outputs will be visible on the map. So when it's displayed to you, it's displayed in a dynamic fashion, and what that means is the results are categorized or binned based on the analysis maximum or the highest burn probability value, the highest pixel of what is being analyzed, viewed, or reported on. So the landscape extent or the area of interest if you've applied one. You can see I've got a little red circle around here. There's going to be a value, and it's going to be a number that may be confusing to people who don't really work in burn probability numbers. In this case, it's 0.0347. So that's why we went with this binning approach. So really, the red bin or the highest bin is 80 to 100% of that maximum, and so on down. So it's relative within this landscape. You can see, okay, the red is my highest burn probability on this landscape, and so on down to the green being the lower and the blue being the lowest. The gray represents non-burnable, and the black is burnable but not burned. So if you wanted to understand what that number signified, it's the number of times that cell burned divided by the total number of ignitions. So in this scenario, and I said hypothetically 10,000 fires, I'm sure it wasn't that, but if you get a 0.0347 burn probability, that would mean 347 times out of 10,000 fires. So 347 of those fires burned that maximum cell. That was the maximum times any cell burned on this landscape during that analysis. Now, I said it's dynamic within that landscape, so it's important to kind of talk about that because it's dynamic based on what you're viewing as well. So here in this example, we've got an analysis maximum of 0.12. That's for here's the landscape that was drawn, here's the buffered extent. If you look at that entire extent, that's the analysis maximum. If you mask that to just look at the landscape within the blue box and not include this area out of here, you can see that everything changes, everything is recategorized. Your analysis maximum is now 0.06, and all the bins and the color coding of these pixels change accordingly. It's still, showing that this portion is higher than this other portion, but now it's saying this is the highest on my landscape. And that's to help you tease apart in these landscapes, okay, there's not a ton of difference, but I want to know within my specific area which is higher than the other. So and so on. If you just look at an area of interest or a specific shapefile and mask it to that extent, it's going to do that rebinning process again. In this case, that's actually, dropping that highest analysis maximum to 0.04. So it's something important. There's a lot of help content on this to kind of help you wrap your head around this. And this is one of the reasons I said we wanted to release this early, because it's new. I want people to get used to playing with this. The other thing to keep in mind is that this is, a single scenario of weather. You'll want to try multiple scenarios. You'll want to try different wind directions, wind speeds, all of them in that worst case scenario. Mostly probably be playing with the wind direction, but also other things depending on what it is you're interested in on that analysis. So in addition to that burn probability output, you'll get a conditional flame length output. So what the term conditional means, it's on the condition of the fire. And if you hit the identify tool, this little eye tool here, and click on an individual pixel, it actually will give you the proportions in each flame length class. These are 2-foot flame length classes, so 0 to 2, 2 to 4, etc. It's going to be classified based on the one that had the maximum. In this case, the highest proportion was in the 8 to 12 foot range, so it's classified as such on your legend in the 8 to 12 category. But you can see, the number of times in those other fires simulated that it fell sometimes in these other ones, depending on if it was a heading fire, flanking fire, backing fire, whatever the influence was that changed that. You can toggle between these outputs, and you can also apply mass. Now, the conditional flame length is not dynamic. That's not going to change when you apply mass and change. That's just a straight output for each pixel. The third output is this derived output of integrated hazard that takes into account both the burn probability and the conditional flame length. So within the map, you click on these little 3 dots here in the layer list, and that will actually open up this legend or integrated hazard box that shows the lookup table, which is a function of burn probability classes, lowest to highest, and then flame length classes, lowest to highest. And the next slide will show this in more detail. That's just to show you can view that while you're on the map. The identify tool will also show you how it was classified, and you can see, like in this previous slide, the flame length was 65.8%, and those higher flame lengths, and the integrated hazard class was middle. So same concept with this integrated hazard. And this is also dynamic because it's dependent on the burn probability value in this lookup table. This is what that matrix looks like, sort of blown up, just to show you that landscape burn probability and conditional flame lengths alone maybe aren't as powerful as a measure of hazard as combining the two. For example, if you've got a relatively moderate flame length, but you've also got a high hazard, that might put you into, or the higher burn probability, that might put you into a middle or higher integrated hazard class. So just another tool available to users. So those are the three outputs. What you can do with these outputs then is you can get reports or download from the modeling playground. You'll have these buttons I mentioned available to you to download from the workspace. You can both download or request a report. When you say request a report, you can ask for the entire analysis area, or you can specify an area of interest if you've already got a shapefile identified for that. And in the playground, I forgot to mention there's a view input button that will show you the inputs used in that model run. And in addition to the inputs, now you're actually getting sort of, we call them inputs or outputs, but you're going to get the total number of fires that were run down here at the bottom. We had that right-hand panel saying in progress fire summary. Now this is going to say completed fire summary. So it ran 39,700 fires, 94.1% of burnable cells burned, and the number of fires that failed was 0. So in this case, you might say, maybe I need to re-look at my inputs because I did not achieve the 98% goal, or you may say that's realistic. For this landscape, it's just kind of a humid, moist environment, and that is worst case, and some of those burnable fuels are just not going to burn even in a worst case scenario. That's kind of user discretion. That tends to only be the case in the more humid climates. The reports, like I said, they'll have burn probability, conditional flame length, and integrated hazard. There'll be a templated map, either the full extent or an area of interest, header information, bar charts showing the distribution of each, the burn probability, flame length, and hazard, as well as a table. This just shows the same example. This is for conditional flame length, but with an area of interest applied. So these values in the charts are specific just to this area of interest, which is identified in the header. And when you do the integrated hazard, there will be a copy of that hazard chart in it so that you can have that chart to reference as it's pulling from the burn probability and the conditional flame length. You can also download the outputs from your model runs. Your model outputs will include the three primary outputs, the burn probability, conditional flame length, and integrated hazard, as well as the fire intensity level probabilities, mid-flame wind speed, fuel moistures, and wind. There's help content instruction on downloading these and displaying them in our map. You also get that text file of the fire size list, and you can use, you also get in the download a file that can be used as an input file for the FlamMap 6 desktop. Just want to make a shout out to the help content. We've got some good help content, and as I said, I think this is a new model. So on the left-hand panel here, you can see sort of under modeling, and then under landscape burn probability, there's an overview, tutorial, description of inputs and outputs, run considerations, which is, I think, the section I have highlighted, which is sort of a tips and tricks or just things to consider. For example, when choosing a landscape extent, I mentioned that you can't compare across analyses, so this recommends choose a landscape extent that encompasses the entire area that you want to compare results in, because you can compare them if they're in the same analysis. So you may want to try and take in your whole district or park if you can within the acreage limitations. There's a discussion on sensitivities, as we recommended you try different inputs and see how it affects the burn probability. Some discussion on that. Simulation time, the discussion of spotting that I mentioned. So since this is new, there's quite a bit of material. I'd recommend that folks go and look at that. Kim, do I have time to show a little bit in the application?
Yeah, you sure do. You've got, we got about 9 minutes or so. 8 or 9 minutes.
Oh, sweet. Okay, I'm talking fast. Okay.
You're doing awesome. Keep it up.
Oh, she's so positive. So once you log into IFTDSS, if you go to the cycle, which we've got here to represent the various tasks associated with fuels management, you'll see the first couple of steps that I listed for doing burn probability are listed here. The first step's really for anything under this landscape evaluation portion. So you've got your create a landscape, and you've got edit landscape. You've got model fire behavior. If I click model fire behavior here, it's going to take me to what's called the playground, which is that choice of those two models that are available. Just want to show you there's also across the banner here, across the top, different ways to get to different places. There's no rules about which way you go. It was built with the intention that you could move around as you chose, depending on where you wanted to go. If you go under strategic planning, that's where the quantitative risk assessment work is going to be. So if you already have a landscape and it's already edited to your satisfaction, you're thinking more about diving into the risk process. This is where we've got the map values. This is where you can select burn probability. There's not much difference here. If you go to the playground, from here, you'll have to select the model of burn probability instead of landscape fire behavior. If I go directly from here, it's just pre-open to landscape burn probability. You can't break it. You can go whichever direction you want. Just to show you, here is where also the map values is that we talked about in the last webinar. It's more under the strategic planning page. And then this next step of exposure analysis and risk assessment. Not necessarily linear, but all available through this page. So if you already have your landscape and you go straight to the playground and you choose landscape burn probability, you say create run, and then here's where you would select the landscape. And then you'll see there's green check marks here. That means these are pre-populated with default values. Doesn't mean you can't change them. So in this case, wind is not yet populated. You just open that up. It's going to default to a gridded wind to account for topography, using Wind Ninja. You can change that if you choose to. Enter your wind speed and direction. Crown fire inputs, again, default to Scott Reinhardt, 100%. You can change those. So you can just open up those defaults and look at them. Here's where you'll put your initial dead and live fuel moistures. You can do it by fuel model if you choose to, by selecting add row and specifying for a given fuel model what those moistures are. Fuel moisture conditioning, I mentioned the default is do not condition. For certain parts of the country, you could say condition, select classified weather stream. It will actually look around and see if there's classified default reference data available. In this case, there's not. I think I chose Acadia Park in Maine. We don't have it for a lot of the eastern US. So you go back to do not condition. Set the simulation time, which is just 4 to 12 hours. The spotting, again, I said it defaulted to 20. You can change that. You select the name and you run it. I'm not going to run one now because it does take a little while, but I'll show you. Well, actually, I could hit run, couldn't I? Let me run one just so you see the progress bar. I'll just copy another one and run it again. So I hit run, then you go back to the playground, and that's where you're going to see the status. So now you can see I just submitted test 3, and in the status bar, it's going flashing there. It's running. As the model initially has to throw down all those random ignitions do its resampling process, so there's nothing in the in-fire progress summary yet. But if you select your row and then look over here on the right, you can see all the inputs that you specified. I can see I'm number 1 of 1 in the queue. Here are my inputs. And once it starts actually running fires, the status will be there. And you can continue to hit refresh, like I said, pathologically and wait for it, or you can go do something else and wait for your email. Let's see. In the Playground, you can also, for completed runs, you can hit download from here. You can hit this view input box that I mentioned that will give you a summary of your inputs similar to what you've got here in the right-hand panel, but it's kind of handy to just screen capture that or something if you need it for something else. And you can also say view on map. So for a completed run, if I say view on map, it will automatically zoom into the area that the analysis was done on and open up the layer list with the outputs that I specified that were tied to this run. So it's landscape burn probability. Burn probability is automatically turned on, but here's my conditional flame length or my integrated hazard if I wanted to view something different. Let's say I want to look at integrated hazard instead. I mentioned that for 3 dots here where I can open up the hazard matrix, and then I've got it available on my screen to kind of reference. I also mentioned the dynamic nature of applying a mask. So that's done at the landscape burn probability output level. You hit the 3 dots and say apply mask. It'll ask you what you want to mask it by. I already have a shapefile. In this case, it's a boundary of a national park, or you could do it just by the turquoise box, the non-buffered extent. You say apply mask, and it will take it a minute, but it'll recalculate and redisplay that scaled to that extent. So you can see it's pretty different now, how it's distributed based again on that analysis maximum, which in this case was 0.0296. If you go to your workspace, I just mentioned that's where a lot of those buttons are available as well. So if I go to my workspace, I can see, let me see, that one was here. You can filter on the left-hand side. So I want to go to model outputs. It's a landscape burn probability, and then I want to request a report, view on map or download. I can say request report. I can say whether or not I want an area of interest. In this case, I've already created one, so it's got a hyperlink. I just click and I can open up that report, and I've got the header information, the templated map, and the bar charts for each output. You can switch in this filtering on the left from burn probability, conditional flame length, integrated hazard, etc. So I think I'm going to stop there, Kim, and let Jen give her example.
Yeah, I think that's good timing. Excellent. One thing, if you could just quickly mention, some folks have asked, with kind of a recurring question here, can you explain just a little bit on the ignitions and how they are random ignitions every time you run the model? However, in the future, we will be able to save those ignitions. Can you just explain that briefly? I've explained it a few times in the questions that have been asked, but if you could just go over that quickly, and then we'll jump to Jen.
I think so. We're going to have a choice. We've designed it, but not yet built it, where we're not going to necessarily just pick one set of the random ignitions for you and say this is your random ignition set that's going to be repeatable, because of the reason that you may want to try some different runs under different conditions, and each of those runs is going to have a different set of ignitions. So if you happen to run one that only gets, say, 1,000 fires, and you don't feel like that's a robust enough analysis, and you want to run it again and try and get something, or you used a wind direction, that's going to result in 10,000 instead of 1,000, we want you to find an analysis that you like, and then you can say, use this set of ignitions again. So you found a set of ignitions you think encompasses what requires a good analysis. Then you can pick that set of ignitions as the one you want to repeat for comparing when you're doing any sort of comparison. I hope that answers it a little better.
Yeah, that's great. And that's being built. It won't be available until early 2021, 2020. So just hang.
We're going to release
tight.
that
We'll
with
let
exposure. Yeah.
Right. Yeah. Okay, Jen, I'm sending it your way. Jen's going to take it from here and show us an example from her work in the Southeast.
Hi, everyone. Kim, can you hear me and see my screen?
Yes, can hear you good.
Great.
And you've got your first slide up. Yep, looks good.
Great. All right. Hi, everybody. All right, so now that you've learned a little bit about the background of landscape burn probability, we're going to take a look at an example of how it can be applied. So you remember from Caroline's presentation, the different scales that IFTDSS can address. And for this example today, I'm going to focus on the unit level, which is best for project planning and prioritization and risk reduction. Some questions that can be answered include, what treatments are feasible? Where can different treatments be implemented and to what extent? How will treatments affect various risk factors? And how will treatments affect potential impacts to HVRAs? So our study area is going to be the Apalachicola National Forest. It's located in the Panhandle of Florida. The forest treats about 100,000 acres annually. And with this amount of acres treated, there's a need for prioritization. And as of now, the forest looks at time since last burn and meets with resource management staff to take into consideration their needs. So no spatial tools are used at this time. Okay, so here I'm showing you how our forest is broken up into burn units or burn blocks. They range anywhere from 100 acres to almost 9,000 acres. And for this example, we're going to take a closer look at the west side. And I chose this area for a few reasons. One, for simplicity, it's a smaller area for this example. And two, this area was hit by Hurricane Michael in 2018 and has the potential for increased hazard due to the additional fuels on the ground. All right, here's the initial damage intensity map from Hurricane Michael that we did. And in the red, orange, and yellow areas, which is in that west side of the forest, these areas had up to 50% of timber damage. And the timber's on the ground and jackstrawed. There's, in the forested areas, the dead fuel moistures, the ones, tens, hundreds, and thousands, the fuel loadings have all increased considerably. Okay, so this is the west side, the burn units on the west side. And on the left, you're looking at the units in the orange and purple. The units in orange are areas that were treated in 2018, and the purple are areas treated in 2019. That's as far as I went back because a lot of this area is on a 3-year rotation. And for our proposed units for 2020, some of them were the same from 2017. So that's why you're only seeing 2 years. On the right, you'll see those same 2018 and 2019, and the first step that we've taken in prioritization for 2020, which takes, like I said, takes into consideration the time since last burn and the coordination with resource managers. So now that you have a background on the info in the study area, we're going to go through the steps in IFTDSS to run a burn probability. So some of this is a little bit of a repeat of what Caroline said, but I just wanted to run you through exactly how I did it for this area. We're going to walk through the cycle, and I'll refer back to the areas in the cycle as we go through each step. So we're going to create a landscape, run a landscape probability, and then create an HVRA set. And for this example, I ran the landscape probability first, but you can create the HVRA set before the landscape probability. So just know that those two steps can be done in any order. All right, so to create a landscape, you want to go to the landscape evaluation in the cycle. And then once you've created on the landscape, it'll take you to that map studio that Caroline just showed you. You can draw a box or you can use an existing area of interest. And then in this case, I drew a box. So the inputs that I entered I used the Landfire 2014 version, went with the 40 fuel models, and then named it and set it or placed it in the work folder. So just wanted to throw out there that it's a good idea to set up those folders in advance. Trust me on this one. It just helps you keep organized later as you start doing more. So when your landscape is ready, you can review it and make edits if needed. In this case, I made edits to the landscape using a shape that I uploaded for that heavy hurricane damage on the west side, and I changed some fuel models and some canopy cover there. And so you can see from the before and after picture on the right that the fuels are much different post-hurricane. So I wanted to make sure that we took that into consideration. All right, next, I created the landscape burn probability. So in the cycle, you're going to go to the strategic planning. And so the inputs that I used, first for wind, I went with the gridded winds. And so in IFTDSS, you can run the generate auto 97th landscape fire behavior, but in my case, I got my values from Fire for Me Plus. So I went with a south wind, pretty common around here to have some sort of southerly component. So I went with 90 degrees and a 15 mile an hour. Went with the Scott and Reinhardt, but again, you can pick Scott and Reinhardt or Fenny. For the fuel moisture conditioning, I left it off because that's not available here, and I didn't create the file myself, but that's something I look at doing in the future. And for the initial fuel moistures, I put in for my deads, I put 4 for 1 hour, 5 for 10, and 6 for 100. And for my lives, my herbaceous and woody, I used 60 and 90%. For burn period length, I used 6 hours, and I left the spotting probability as the default. So this next one are the results, and you saw these also earlier. So here you have the burn probability, the conditional flame length, and the integrated hazard. And I also have those initial 2020 proposed units overlaid here. So this kind of gives you an idea to look at these 3 results with those burn units. And then another way to look at it, as Caroline mentioned also, is to apply that area of interest, which was really useful, I thought, in this case. You can see here, just by looking at it, that it's kind of apparent which units I would want to prioritize based just on this, on the burn probability, conditional flame length, and the integrated hazard. So you could use this for prioritization, but it doesn't take into account the HVRAs yet. So next, I looked at the reports, and this is also, to me, really useful. I ran it for the area of interest, and so it also, it gives you a visual, but it also gives you some quantitative information with in this case, the conditional flame lengths. So I could see in these areas that the majority of my conditional flame lengths were in like the 4 to 8 categories, and there was quite a bit in the 8 to 12 as well. So this helps give me that information, that quantitative information that I could use to make decisions as well. So then I created an HVRA set, and then a cycle. This is in the strategic planning, and first I selected the geographic extent, and then chose which HVRAs and sub-HVRAs that I wanted. So I had communities, infrastructure, and ecosystem function, and some wildlife. And then I also had a few additional data sets that I wanted to upload. There were TME species. I had a red cockaded woodpecker layer and an endangered plant layer, and these are both influenced by fire. So for healthy red cockaded woodpecker habitat, it requires frequent fire for wiregrass production. And then the endangered plant layer contains species that are fire adapted and require frequent fire to maintain their habitat. So these are 2 layers that are something that we'd want to consider in our prioritization as well. So then lastly, here are some screenshots from IFTDSS. The one on the left is the map of the area with the HVRA set, and the one on the right is looking at the HVRA set with the integrated hazard. So it looks a little busy here, so I'm going to jump over to IFTDSS so I can show you the swipe tool live, because it's much more interesting than looking at a static screenshot. So here we are, and then I'm in my workspace here, and then I'm going to go to the folder. And from here, I'm going to go to my landscape burn probability, and I'm going to view on the map. And this is similar to what Caroline just showed you, how it zooms right in there. So let's look at conditional flame length. And then I can add some of my layers that I'd like to add. And so what I want to look at is my HVRA set that I created, and then my proposed burn unit. So again, see, so it looks pretty busy, but what's really neat is this little swipe tool. So it's up here at the right hand corner. And I want to do it on my HVRA set. So here we're looking at the conditional flame length with those burn units. And we can zoom in just a little bit closer. Let it load. And so you can swipe. And what I'm swiping is the HVRA set. So this will give me a better look at, you know, each unit up close, you know, what these conditional flame lengths are. And then I know you don't know because this is the first time you're seeing this, but some of these circles are the endangered plants, and these polygons are the red-cockaded woodpecker habitat. There's some other woolly areas in here, and this long green one is a vertebrate habitat that was in the HVRA national data set. So this is just a really good way to really get in there and analyze this closer. So I'll go back over to presentation. All right, so that's all for the example of some of the ways you can use the burn probability for your prioritization planning. However, coming soon is the exposure analysis, which will allow you to view and at some point analyze the interactions of the HVRAs and the integrated hazard. So you can use this landscape burn probability for prioritization, but the exposure analysis will take it a step further to spatially analyze the HVRAs across the landscape. And that's it.
All right, Jen, thank you. That was great. Nice example. I think that really illustrates well how that can be applied. So I'm sure folks have some ideas now that they've seen that example and Caroline's demonstration, that hopefully the wheels are turning on how this might be useful to you. So let's see. The one question came up again about the saving the ignitions, and just wanted to answer that one out loud here since we have a second. Probably at the end of January is what we're looking at. End of January, early February is when we'll have that save your ignition feature. So we'll let folks know when that's ready to go, and we'll send out some messages to everybody on how that's going to work. So you'll see some info coming on that once we're ready to release that part. Let's see, the other question that came up here right at the end was, people have asked, and we've gotten this question quite a bit before, is can you upload your own land fire data? Like if you have your own landscapes that you've made, can you upload that into IFTDSS and then run that? And the answer to that is no, not right now. We're going to have the Landfire 2016 data loaded in January. So as it becomes available in Landfire, we'll be loading that into IFTDSS beginning in January. But at this point, you can't upload your own Landfire data or your landscapes. We might be able to do that in the future, but we're not quite set up to do that just yet. But it is on our list, and people do ask us that quite a bit. So that was a few questions. There's a bunch of other questions in here, and I know we've come to the top of the hour. So what I want to do is just really quickly wrap things up and let you know how we're going to manage the recording of this and then sharing the information. Again, the recording will be posted. Hopefully you guys can see my screen. It should be the IFTDSS main screen here. Great. If you go to user support, webinars and training, and that will take you to the recorded webinar area. We'll upload the webinar recording here. I'm also going to upload the questions and answers that people have asked. So you'll be able to click on that and look at the questions and answers. If you have additional questions for us, we do want to hear those. So there's a couple ways you can do that. You can either go, again, to the user support tab and go to the support forums section. And in that case, we have two things. We have a questions and answers forum here where you can post a question, and either us or other users can go in and answer those questions. And if you have an idea for us, you can also load up your idea here, and we'll take a look at those and respond as well. We'd love to hear how people are using IFTDSS, how it's working for you, what types of projects you're using it for. So please feel free to share those with us here as we share these examples with other users. They always get great ideas based on our user community. So I wanted to make sure everybody knew that forum is available and where those recordings will be saved. So we thank you guys for joining us. We wanted to keep this to an hour, and we hope everybody has a great holiday season after the new year. Once we have the exposure analysis finalized at the end of January or February, we'll probably be doing another webinar on that in February sometime, and keep looking for our flyers and our MailChimp messages that come out to the user community, and we'll keep going that route to get information out to everybody. So have a great holiday season, and we'll see you in 2020.
Thanks, everybody.